So there we have many of the different components that make up the satellite itself, which will orbit around the moon Europa, and we can see that we're designing those inside of the payload envelope that we defined earlier. As we go back to the overall assembly, let's move on to some other parts of the spacecraft. Inside of the orbiting satellite is the Lunar Capsule, which will be jettisoned down to the surface, and inside of that is the lander vehicle. There are many components which make up the lander vehicle assembly. We'll focus on primarily the more challenging parts of this project. For example, the spiral connection cord, which goes from the camera to the connection socket on top of the probe canister. And you can see that we can actually draw the spline curve in 3D, and we can also edit the path in 3D. Now to create the helical cord, we'll use the Helix tool. Simply click on the object and set the number of cycles and the radius and all the helical parameters to create a nice spiral helix, which will follow that path, and we can edit that path. So as our design changes, we can very easily go back and modify the position of where that helical cord goes. And of course, the Helix tool can be used for the springs and shocks and coils also. Towards the bottom of the lander, we want to create a protective shield so as the lander is traversing across the surface, it doesn't get caught up on any jagged outcrops on the surface. So we create a series of wires. Here's an exploded view in which we've traced the bottom plate and added a few extra circles and some spline curves. And we'll sort of combine those together to create a wireframe skeleton shape that we want. Using the skin tool will shrink wrap or sort of saran wrap a surface around all those wires. And this is a NURBS object, so it has a set of controls that can be used to further edit that geometry, to modify the shape after it's skinned. For example, if we were to turn the track assembly back on, notice that the surface is going right through the track drive assembly. No problem, just simply grab hold of those controls and move those around to reshape it, almost like a flexible rubber surface that we can modify and sculpt into the shape that we want. Now towards the front, we're going to do something a little bit different. We'll create some other geometry that sort of defines the working envelope of the track drive assembly system. And with these other objects, we can use those as cutting devices, so we can trim the surface with these other objects to create an opening in the surface so the track drive components will then stick through that bottom plate. Or if we undo, we can also trim and also stitch and round the pieces together. So I can click on the inside and notice that I can trim, stitch, and round with a specific radius to create the additional features in the surface like we have here. And now if I turn the track assembly on again, we can see that that feature actually creates a smooth recessed area in the surface to match our track drive assembly. On the top of the lander, we need a protective shield around the top components to protect it from the intense radiation and the intense magnetic fields that are on the surface of Europa. So once again, we just start with a series of wires, and with that network of wires, we can then skin a surface around all those wires. And this is a NURBS object, so we can go in and modify the controls on that. We can reconstruct it by increasing or decreasing the number of controls to further modify that shape later, if we desire. Towards the top, we can do a cross skinning, in which we can take one cross section and have it follow a single path. And we get a shape that looks like this. Now we can attach one NURBS surface with the other by stretching and pulling the edge of one surface to match the other. Or we can blend, which keeps both of the surfaces fixed and creates a new intermediate blended surface in between those two objects. Now if this is foil, let's give it a surface style texture that looks like foil. And notice that when we turn the rest of the lander assembly on, we need to punch some holes into the foil so that the antenna and the satellite dish can stick through. No problem. Use the Curve on NURBS tool, sketch a spline curve, and notice we can draw right on the surface of that complex 3D shape and use that as a profile to punch a hole through the object. We can also draw a separate profile, like for example the circle on top here, and we can trim by having that circle project straight through the other object to create the perfect circular opening on top like that. And this is how some of the more organic type objects were created for our lander vehicle assembly. So we have our protective plate on the bottom, and we have a protective foil on top, and the helical connection cord on the top portion. And now here's the lander on the surface of Europa. formZ is a general purpose 3D solid and surface modeling program, so it's used by mechanical design, product design, and also architecture. So there's a terrain modeling tool for creating 3D terrains from contour data, or we can also import digital elevation model data, DEM data, or point cloud data from satellites in order to create 3D terrains, or just lost some nerve surfaces if you want to recreate or emulate any type of environment. Now, to further enhance the virtual environment that we have here, we'll add some lighting. You can see that we'll add a sun light source, and we can dynamically or graphically move that anywhere that we want. formZ does have a database. We can choose any city in any part of the world at any given time, but since we're 425 million miles away from Earth, we can actually type in our own longitude and latitude coordinates to position that sunlight source. If we look at the solar panels, we see that we can, through the Information Attributes tool, get the mass properties and the engineering analysis properties for the surface area. And we can take those solar panels and move those and rotate and transform those into any array that we want. And wouldn't it be nice to take all this data, the actual direction of the light source, the surface area of the panels, and the position of the panels, and calculate the amount of solar energy that would be able to be generated from those? Well, formZ doesn't have that tool. But formZ does have an open architecture, so you can create, using scripting or C-compiled code, you can create your own tools. You can customize any of the existing tools and actually further enhance any of the existing capabilities in formZ. So we actually created our own solar power calculator. And based on the position of the sun light source, we have a time continuum because one day is 85 hours. We can actually slide that across, and based on all these different properties, it'll calculate the amount of output power in watts of those solar panels.